Okay guys, today our topic today is going to be derivative of a function. Yeah, derivative of a function. So let's go straight to what we have here. They say think of a derivative as the rate of change of a function. It's like a road. The derivative tells us if the road is going uphill or downhill. So see what we have here. Say the derivative tells us if the road is going uphill or downhill. Let's dive straight to the example to see what we're talking about. For example, they give us a question here. F of x is equal to x raised to the power of 2. Therefore, f prime of x, or the y over the x, is equal to 2x. Okay, let's think of a situation whereby, okay, let's say x is equal to 2 and x is equal to minus 2 and x is equal to 1. So if after imputing all those values as x equals to 2, minus 2 and 1, these are what the value gave us. That's the slope. This is what it gave us. X is equal to 4, x is equal to minus 4, and x is equal to 2, which means this is an increasing function, this is a decreasing function, this is an increasing function, because this has a negative value. So the function now, it tells us, sorry, the derivative tells us if the road is going uphill or downhill. So now this function now is going downhill, this function now is going uphill. So that's what derivative is all about. So now let's move towards derivative in ML. That's machine learning. What derivative is all about in ML. So they say in ML, we train model to reduce error called losses. In machine learning, you are often going to hear the word, what's it called? Error and losses, cost function. All those terms are terms used in ML. But just anytime you hear the word loss or cost function or loss function, just know that it's error. Yeah, so in ML we train model to reduce error called loss, and to reduce this error we need to know which direction we should move the weight to make the loss smaller. You see, to reduce this error we need to know which direction we need to move the weight to make this loss smaller. And this direction is found using derivative of loss function. Okay, this is a small example we have here. F of x is equal to 3x squared plus 2x squared plus x. Of course, the f prime of x will be equal to this value. On your own now, you should try to find the what's it called, the direction to move the weight to, in order to make the loss smaller at x equals to 2 and x equals to minus 2. Just try to find it at your own. Let's say where x equal to 2 and minus 2, to know the direction to reduce the weight in order to make the loss smaller for a particular prediction. So guys, let me just treat something here. You are hearing of the word loss, you are hearing of the word weight, you are hearing of the word error, although everybody is familiar with the term error. So let's just go through what those three things are all about. So the term loss, cost, error, weight. So these are terms used in ML most often. They are used in ML often. So this term now, loss. Loss now means that is the average error. You see, loss and error are the same thing. Loss and cost. They're also called error. So let's just read this one. They're also called error. So lost and cost are also called error. So this loss now can also be called lost function. This cost can also be called cost function. We'll be treating the topics very soon in my previous videos. But this loss now, it means prediction made for one single, sorry, it means error made for one single prediction. While this cost function means error made for average prediction. Yes, sorry, the average error made for an entire prediction. So this loss now means a single error for a prediction, while this cost function means average error for the entire prediction. So that's what it means. But this weight now, you've heard of weight. Weight is a numerical value that is assigned to the model to tell the model how important a particular input or a feature is. That's during the training data. You that the what's it called? The weight now tells the model how important a particular feature is during the prediction. So that's I think that's all we need to know about derivatives. Okay, it talks about how high, sorry, it tells us if the road is going uphill or if the road is going downhill. And also these are the applications. uh It tells us which direction we should move the weight to make the loss smaller. So that's all we need to know about derivative in machine learning. And if you have more questions, you can comment it down at the comment section so that we'll get to treat it more. Guys, see, just to make everything much more, just to summarize everything, these are weights now. Weight is just, like I said, the numerical value that you give to the model to make it okay. See that this particular feature or this particular input is important. So this weight now, let's go towards the mathematical example of this weight. I know we all know this formula, equation of a straight line. Y is equals to mx plus c. Yes. So this is y equals to mx plus c, where this one is our slope, this is our intercept. The m is our slope, the c is our intercept. So this weight now, in normal prediction, or let's say when we go towards so when we start to go deep, we're going to be using other aspect of maths to understand how machine learns. So this for a particular prediction, this is the formula for it. Y is equal to wx plus b, where b is our base, w is our weight, x is the input, and y is the prediction. Y is the actual value we are looking for. See, there's nothing much, there's nothing different between these two. This is our weight. It tells us if this x, if the input, it tells us more about the input. And this is the base, this is the intercept. So guys, just to summarize everything on this derivative is just basically your dy over dx. Yes. Let's say for example now they give you y is equal to, like we said, x squared. So the y over the x is equal to 2x. At x equals, sorry, at x equal 2, that means the y over the x equals to 2 times 2, which is equal to 4. And this 4 is your m is equal to 4, which is your slope. Which is this slope we're talking about. So it shows us this derivative shows us the direction to which we will move our weights to in order to reduce the error, which is also the loss. So that's just what derivative is talking about.